This will do it. Does that work?
Yes, that works.
Okay, wonderful. Well, I really appreciate this opportunity to talk to the Reparations Task Force today about the topic of physical health. And physical health clearly has to be a big part of this argument and this story. As a little bit of a refresher, at birth, a female African American in this country has a life expectancy about 3 years less than a white counterpart. And that difference is even more stark for males. It's about 4.5 year difference in life expectancy. Remarkable statistics. And what underlies this? Well, a lot of long-term chronic conditions like hypertension, obesity, kidney disease, heart disease, low birth weight, and so on. And here are differences in hypertension by groups, right? So here you see African American versus other groups, notably higher, right? Now, before we proceed and have this conversation as part of this panel, I think it's important to keep in mind that genes are not a cause of these race-based health inequalities that we see here in the United States. I think many of us Americans are socialized into thinking of race as a kind of indelible property of individuals that's sort of inscripted in our genes. And that's just not how it works, and that's not what the genetic data say. And let me give you an illustration of this. So if we think about all of the genetic variability on the planet, all the human genes that are out there, if there were races, you would expect them to cluster into racial groups, sort of like this picture here, right? With some overlap, but relatively distinct from one another. What the genetic data actually show is something more like this, where European and Asian genetic variability is a smaller subset of the original African variability. And this makes a lot of sense if we think about the history and the sort of evolution of our species. Modern humans evolved about 200,000 years ago in Africa. There's been a lot of time for diversification, right? Different language groups and cultures and so forth to, for genetic variability to emerge over that time frame. And then about 50, 60,000 years ago, groups started to migrate out up the Nile Valley or up the coast and populate Europe and Asia, right? But clearly they're just taking pockets of that original variability, and that is why the diagram looks like this as opposed to a kind of racial diagram as people would conventionally think of it. So the idea of genetic race just doesn't stand up. As important, if not more so, is the fact that when we look within countries, how people are categorized into groups, and in the United States into races, is a product of local, historical, political, social forces, and it's not based in genetics, right? And in the United States, we're all very familiar with this. Obama made, of course, incredible headlines by being the first Black president, right? But if we look back here at our future first Black president, here he is with his grandparents, and here he is with his mother, a European descent woman from Kansas, right? But because we live in a society where any indication of having non-white ancestry at all puts you into that non-white category, the fact that he has a Kenyan father makes Obama classified as Black in this society. And this one drop rule, I think, just illustrates how when we talk about race, it's a social construct. It's not based in something genetic and objective. Okay. Now, what I'm not arguing for is that genes don't matter to our biology, because clearly they do. There isn't a trait on my body that isn't influenced by genes. But there's no evidence that genes account for why one group is over here and another group is down here, okay, when it comes to health inequality in this country. Here's a study that pooled all the data on genetics and racial disparities a couple years ago, and the authors concluded the accumulated evidence for genetic contributions to cardiovascular disease disparities in Blacks versus whites has been essentially nil. A more recent study, 2020, published in the Journal of American Medical Association Cardiology, large study, 2,500 individuals and so on, and again, adds to the existing evidence against the genetic basis for population level racial disparities. So genes are not a part of this story. What we do know is that health inequality traces to things like income, educational opportunities, differences in discrimination and racism, healthcare access, and so on. It's these social factors that drive the health and the biological differences. So that's what we've known for a long time, that those chronic differences in experience and things like stress and discrimination and so on are going to drive health inequality in the country. But what I want to talk about today for the rest of my talk, I'm going to add to that story, okay, and talk about some work that's been done in the last couple decades that's showing that experiences early in life, starting in utero and continuing into infancy, can lead to durable biological changes that also influence health across the life cycle. So this is another complementary piece of evidence for this social determinant story. I'm going to start with just a little bit of the work that we've done in the Philippines on this topic. I've been working there for about 25 years. And this graph here, what it shows is we're breaking the population down on the basis of their waist circumference, how much body fat they have around their belly. And those who have the most body fat have the highest insulin levels, so that they have the highest risk for diabetes, as you would expect. Here we break it down further on the basis of their birth weight, right? And so the light bars are the lowest birth weight individuals. And you can see that the folks who are relatively light as adults, their birth weight doesn't matter that much, matters a little more for those in the third quartile, and those who are heaviest as adults, it matters quite a bit. And in this sample, in this population, the folks with the highest risk for diabetes are those who are born small, born thin, but then go on to gain weight and become heavy as adults, right? And the difference across those birth weight groups is about 25%. So it's a fairly substantial impact. What this finding is an example of is a field called the Developmental Origins of Health and Disease. It goes by the acronym DOHAD. The basic idea here is that the roots of adult health trace in part to experiences during intrauterine and early postnatal life. And this is an important part of this overall story of the social origins of health and equality in this country. Well, where did this idea come from? Well, starting in the 80s, late 80s and early 90s in Britain, studies started to come out showing relationships like this. Lower birth weight individuals had higher risk heart attack as adults. And that inspired this idea, a model in which a fetus that's stressed or undernourished is going to slow its growth rate, and you're going to get a low birth weight as a result of that. That we've known. But what's new is the idea that the fetus is also changing all these aspects of its biology, how it handles cholesterol, glucose, where it puts fat on the body, blood pressure regulation, immune function, and all sorts of things, stress biology. These are relatively durable, okay, and they persist into later life to influence risk for cardiovascular disease. Now, everything I've shown you so far is birth weight, which is a very crude marker of prenatal nutrition, but animal work, okay, that is more experimental, replicates these findings. So this happens to be guinea pigs, and you can see that this is glucose levels. So this is sort of blood sugar, right? And their fasting glucose levels are here, and then they effectively eat a meal, and their glucose shoots way up, right, after the meal. And then their bodies are producing insulin to remove that glucose from the bloodstream and bring it back down to fasting levels, right? Now, the open circles right here are animals whose mothers had their diet restricted when they were pregnant with them. And you can see that they're clearing their glucose just fine, just like the other animals. But when you look at their insulin, the story is very different. You can see that under fasting conditions, they're overproducing insulin. And then after that meal, they have this exaggerated insulin response. So they're clearing their glucose, but they're having to work a lot harder at it. They're having to overproduce insulin. This shows that their tissues are resistant to the effects of insulin, and that insulin resistance is what leads to diabetes. So this is a nutritional stress imposed on a mother during pregnancy, leading to diabetes in their offspring as adults. All right, so what accounts for this memory, if you will, of this nutritional stress that's happening prenatally? And part of this story, I'm just briefly going to mention it, is what we would call changes in the epigenome or epigenetic changes. And later speakers are also going to talk more about this. What these entail are chemical changes to the chromosomes, right? So you've got the double helix of the DNA. These are little chemical tags onto those chromosomes, which influence which genes are silenced and which genes are turned on. So it's not really changing your DNA or changing your genes, but it's kind of influencing which can be expressed or not. And that can be influenced by the environment, especially early in life, and persist in our bodies as we age to influence health later. All right, so one example of that, I'm not going to go into great detail, but in rats, sort of like what we just saw with guinea pigs, prenatal nutritional stress leads to epigenetic changes in the liver that contribute to adult diabetes. So that's an example of how epigenetics is part of this story. So when we see these very crude relationships in humans with lower birth rate being associated with diabetes, the animal work really suggests that there's something about nutrition prenatally that is driving these relationships. Now, it's not just nutrition. It's also psychosocial stressors that the mother experiences can have very similar effects on biology. I'm just going to show you this very quickly. These are sheep, Okay, and here you can see that, again, it's the same sort of thing where glucose is given and you see the insulin going up, right? Just like we saw with the guinea pigs. The control animals, their insulin is down here, but the animals who are exposed to higher levels of the mother's stress hormones during pregnancy, as those being exposed to a psychosocial stress, you can see that they're overproducing insulin, they're insulin resistant like those guinea pigs were. And over here we see the control animals, and here's an animal that's exposed to high levels of stress hormone that has higher blood pressure. Okay, so psychosocial stress also has those kinds of intergenerational effects. So to summarize, developmental biology is sensitive to prenatal and early postnatal conditions. Maternal psychosocial and nutritional stressors lead to durable biological changes in offspring that elevate future risk for cardiovascular and other common diseases. And the implication of all this is that the mother's experiences of environmental stressors can have lingering impacts on adult health in offspring. Now, that's the background. What I'd like to do in the second part of my talk is consider how some of this might play into the issue of race-related health inequality here in the United States. And we already talked about some of the major sources of health inequality, things like heart attack, stroke, diabetes, hypertension, and so on. Well, there are also inequalities in early life, prenatal conditions as well, things like prematurity, low birth weight, and intrauterine growth retardation. So here's a figure showing the disparities in low birth weight, about twice the rate of other groups when you look at African Americans, right? Now, the DOHAD literature that I just showed you raises the question of whether these early life health disparities might in part be setting up risk long-term for some of these adult health disparities. And before we go down that path, again, we have to ask the question, okay, we've got these disparities in birth weight, right? Might that trace to genes? I mean, that's a reasonable question. And there's really no evidence for this, okay? There's a lot of evidence against it, in fact. And so one source of that evidence comes from interracial marriages. If this is about sort of African ancestry genes and the contribution of those to lower birth weight, then you would expect similarly low birth weights if the father is of African ancestry or the mother is of African ancestry. And that's not the case. If the mother is of African ancestry, married to a white father, about much higher rates of low birth weight and very low birth weight compared to if the mother is white and the father is black. So it's something about being black in utero, right, as opposed to a genetic contribution of African ancestry. We also see evidence of this from recent U.S. immigrants to the United States. So these are data from Illinois, and here, this big line here is the white population, right? And you can see their birth weights are here, and this dotted line is African American birth weight distribution. So it's shifted to the left, meaning that the average birth weight is lower. Now, back here, you can almost not see it, is another line that looks just like the white line, and that's African-born blacks, first generation coming from largely from West Africa. Look almost identical to white birth weight distribution. Now, these researchers did something very clever. They went and they tracked down the offspring and the grand offspring of those immigrants, and what they found is that the birth weight distribution quickly started to shift to the left after just a generation or two and start to look more like the African American birth weight distribution. So there's overwhelming evidence that there's something about being black in America that is driving birth weights down. It's not a genetic factor. We know some of the factors that contribute to this: differences in education, residential segregation, poverty, racism, discrimination, and so forth, the same factors that we already talked about. Here's a study that shows that 3 or more self-reported events of racial discrimination greatly increased odds of giving birth to a low birth weight baby. Black women in this study were about 4 times more likely to give birth to a low birth weight baby compared to white. If you account for discrimination, that's greatly reduced and it's no longer significant, right? So this is the kind of evidence we have for discrimination and factors like that driving those health inequalities. This is an amazing study. This is all births in California, and you see that the likelihood of a low birth weight baby is doubled among ethnically distinctive Arabic-sounding named women in the year after the 9/11 attacks compared to that same group of women the year prior to the 9/11 attack, showing the effects of the kind of systematic racism that occurred after those attacks on low birth weight rates in this particular group. Okay, so let's start to summarize some of this. We have stressors, things like discrimination, racism, and so on. We have positive factors like coping and social capital, and buffering that come together to influence the mother's level of stress, which then influences the fetus. Now, what we've known forever, for a long time, is that is going to drive prematurity, intrauterine growth retardation, low birth weight, these kinds of perinatal or neonatal outcomes. The DOHAD literature that I've been talking about shows that the story continues, that there are also going to be health effects on adult health outcomes related to stress biology, blood pressure, and so on, right? And I already showed you some of the evidence for this from places like the UK, from our study in the Philippines. It also works here in the United States, not unexpectedly. Lower birth weight, higher blood pressure, higher cholesterol, higher insulin resistance. This is in black and white participants in Louisiana from the Bogalusa Heart Study. Here's a fascinating study. This was a former student of mine looking at the effects of ethnic discrimination during pregnancy in New Zealand. And more reports of ethnic discrimination, mothers had higher stress hormones, cortisol, during pregnancy. But then what she did is you can actually have babies spit in a tube and measure their hormones from that. So she had them spit in a tube before and after their vaccines, the normal kind of routine vaccinations that they get, which is a stressor, obviously. And what she found is that the kids whose mothers reported discrimination during pregnancy had a much bigger stress response to that stressor of being vaccinated, showing that there are likely intergenerational effects of stress on stress biology in the next generation. Okay, so we have lots of evidence for this kind of long-term effect of early environments on all of these factors here. Now, unfortunately, this story does not end there, because some of these adult outcomes, like changes in stress biology or increases in blood pressure or increases in your circulating level of glucose, these in turn can feed back upon the gestational environment of the next generation, all right, and have impacts on the grand offspring potentially. So here's an example of that. Here we see that hypertension going into pregnancy greatly increases the likelihood of giving birth to an intrauterine growth retarded baby, mild or severe. All right, so we see that low birth weight predicts high blood pressure, but then women with high blood pressure in turn are more likely to give birth to lower birth weight babies in the next generation. So you have this kind of potential for an intergenerational process. Now, so far, I've only talked about the low end of the birth weight distribution, small babies, nutritionally stressed, and so on. But there's also risk associated with being too large. And this is increasingly an issue with the obesity epidemic. And what can happen here is a woman who has uncontrolled diabetes because of obesity, or just because she's diabetic, her glucose levels will be higher, right? And this will cross the placenta, lead to a larger baby that has more baby fat itself, and also will have changes in their metabolism that increase their likelihood of becoming obese and diabetic themselves, increasing the likelihood that they'll be diabetic mothers and pass on the same characteristics to the offspring. Now, this is not simply a story of genetic inheritance. Obviously, genes could be part of this, right? But we have a lot of evidence that it's not. So here's an example of that. We can look at studies where women have gone through gastric bypass, right, where they lose a lot of weight because of a surgical intervention. And before that bypass, when they're obese, 22% of their 12-year-old kids are obese. But then they go through the bypass, they go through the weight loss as a result of gastric bypass, lose weight, and the children born after that, only 3% of them are obese. And not only that, but there are also benefits and improvements to their blood pressure, diabetes, and cholesterol compared to their same-aged siblings, right? So there's really good evidence, I think, for a kind of intergenerational effect, in this case, of being overweight and of weight loss, the benefits of this across generations. So I think there's good evidence that these early life factors are going to set up risk for some of these late life factors, and that not only that, it's going to be a kind of a fading effect, but nonetheless, there is likely going to be some perpetuation of those effects that go beyond that. And we can think of it this way here, where prenatal stressors set up fetal biology in a way that persists into adulthood, that then sets up the gestational environment and so on as a sort of, again, probably a fading effect through time, but nonetheless, this is probably part of the story. Okay, so to wrap up, African Americans have lower average birth weights. Those low birth weights trace to social causes. There's no evidence for genetic contribution to them. And then those low birth weights in the sort of constrained prenatal environment that we've been talking about can lead to adult cardiovascular diseases, right? It also leads to more rapid aging, cognitive decline, many other things that we didn't talk about, but a lot of this work has really focused on cardiovascular disease. Some of these in turn, things like having high blood pressure or high glucose levels, can then adversely impact the gestational environment of the next generation. And then this is the low birth weight end. We also talked about how obesity can kind of beget obesity through a sort of separate but similar kind of pathway that I just talked about. So the take home of all this is that unequal social environments influence racial health inequality cumulatively via kind of wear and tear, the way that we've traditionally viewed it. But there are also these effects of these life course and intergenerational pathways, these newer pathways, that this is also a part of this story. Now, I think this is an important piece for any case for reparations, okay? Because there's evidence that all of this could be reversed through economic, educational, and residential mobility in this group. So here we see an example of this. African American women who are in the lowest SES quartile, right, and don't sort of stay there statically in the lowest income quartile, you see that 23% of their babies are small for gestational age. But if they have upward economic mobility, right, they move up one quartile, then you see it go down. If they move up 2 quartiles, it goes down further. If they move up to the top quartile, it's drastically reduced, right? So this is for SGA, small for gestational age, but we also see that for preterm birth, for low birth weight. So I think that the developmental origins research that I've been talking about today, that I've been reviewing, shows that policies that improve these newborn, these perinatal, these infant health outcomes are also going to help narrow the racial gap in adult health. So this is partly a story about how health inequality today traces to injustices in the past. That is certainly part of what this is about, but it also shows that policy changes that improve things now are going to have benefits that reverberate into the future as well. And that's all. Thanks.